Okay, hello everybody. We're going to do a truss calculation for this three-member truss here today, and I'm going to walk you through the first problem in your packet. Remember, there will be another problem very similar to this that you will do on your own. You can follow along with this video, and then you can use this video to help you answer the second problem, which will be very similar, just with different numbers and slightly different shape. So we're looking at this three-member truss right here. Our first our step 0 is we want to make sure that this truss is statically determinate. We're going to satisfy this formula, 2j equals m plus r. Well, j stands for joints. I've got 1, 2, 3 of those, so I know I'm going to have 6 over here on this side of my equation. I've got 3 members, 1, 2, 3, and reaction forces. Well, I get 2 from my pin support, 1 from my roller, that's 3, so I'm all good. I'm statically determinate. To get started, I'm going to draw a free body diagram of my truss for step 1. I want to show all the applied and reaction forces. Well, I already know I'm going to have 3 reaction forces, and I can see that I have 1, 2 applied forces up here. So I'll draw the shape of my truss. All right. And here's joint A down here. It's a pin support, so it's going to get 2 reaction forces, RAY and RAX. Over here I have my roller support, which just gets 1 reaction force. We'll call that RCY. And I'll show my applied forces as well. Our second step is we're going to use our static equilibrium equations, which I've listed for you right here, to find our reaction forces. So I'm going to start by thinking about the sum of all of my x forces. Well, here's an x force right here. So got 0 equal to this force, which is 100 going to the left, so I'm going to call that negative 100. My only other x force is RAX. Do a little bit of algebra, and I figure out that RAX must be equal to 100 pounds, so I can write that down here where my answers go. Okay, now I'll add up my y forces. So I've got 0 equal to, well, I've got negative 50, show that right here, right? That's 50 pushing down, plus RAY, plus RCY. So a little bit of algebra, and I know that RAY and RCY have to add up to 50, but I don't know what they are yet because I still have 2 unknowns. So now let's go ahead and think about our moments. Well, I'm going to choose my pivot point to be right here at my pin support. Put a little pivot there. And I want to think about how these different forces are applying a moment. So let's start with RCY. Remember, a moment is a force times a distance. So RCY is my force multiplied by the perpendicular distance back to the pivot, which I know is 8 feet. So there's my first moment. Now I also need to think about positive and negative, and I can use the right-hand rule. My thumb's coming up out of the paper. This is going to form a counterclockwise revolution, so I know that that's going to be a positive moment. Well, technically I don't know which way RCY is going yet, but I'll keep it positive. That's true. Now let's think about this moment right here. So I'm talking about this 50 pounds. Well, I know that that's going to cause clockwise rotation, so that's going to be a negative moment. 50 is my force. My perpendicular distance would be not this tall distance, but the distance across here, which I believe is 7. 1, 2, 3, 4, 5, 6, 7. Yep. The last one is going to be this 100 pounds, which is going to, let's see, that's going to cause counterclockwise. Yeah, counterclockwise. So that's going to be a positive moment. Plus 100 times, now here, I want to use the vertical distance, which is 9. All right. And all of this is equal to 0. All right. Sum of all moments is equal to 0. So I can rewrite this 8 RCY minus 50 times 7 minus 350 plus 900 equals 0. 8 RCY equals, let's see, add 350 to the other side, then subtract 900, negative 550. All right, and I'm just doing algebra here, combining like terms and solving for my variable. So I end up getting RCY equaling, divided by 8, negative 68.75. Now, very importantly, we must remember that when we're doing this moment calculation, we are in moment mode. MM, that stands for moment mode. That means the RCY is causing a negative moment. But it might not necessarily be a downward force. So if I think about a negative moment is going to be clockwise rotation, so in which case that force would have to push down in order to do that. All right, so I need to actually flip the direction of this arrow. And RCY is negative 68.75 pounds. Kind of makes sense because this 100 pounds is pushing, trying to lift this truss kind of up. It's kind of rotating it off, so we need a force that's going to pull it downwards. And the roller support can do that. So now that I know RCY is negative 68.75, I can plug that into here. 50 equals RAY minus 68.75. So RAY is equal to 50 plus 68.75, 118.75. I'm going to go ahead and round that. And I'll round this one as well. Negative 69 pounds. Just make our lives a little bit easier. So there's our answers for our reaction forces. So that's going to be pushing up, and RAX is pushing to the right because it's positive. So that's what my answer looks like. Now let's go ahead and move on and solve for our internal member forces. Okay. So first thing I want to do is draw a free body diagram. My camera down just a hair. There we go. Draw a free body diagram of each joint. Okay. Well, let's just look at my answers on the previous page. Okay. See if we can move this over. There we go. All right. So joint B. There we go. Joint B. All right. Well, it has these applied forces to it, 50 and 100. And it also has these internal member forces that I can show like this. And we'll call that FAB, FBC. I don't know why I started with joint B here. Usually I start with joint A. I don't know. It was just calling to me, I guess, because it had the applied forces. Now we'll do joint A. Sorry, this is kind of a weird way. Well, it gets the other half of this force. That's the internal member force. Notice I'm drawing these arrows unfilled in because I don't actually know which direction they'll be going. Now, joint A also has RAX and RAY, which we solved for. So you have RAX is equal to 100 pounds, and you have RAY is equal to 119 pounds. The only other force it gets is FAC, which is formed by this member right there. So I can draw that coming from both sides. I'll finish up with joint C, which gets the other half of FBC and FAC. And it gets one reaction force, which is RCY, which is pulling downwards with 69 pounds. So there you have it. There is your free body diagram for the whole truss. Now, step 4, we want to redraw each joint showing only the X and Y components for all forces. So here we're looking for forces that don't have, that are diagonal. If they're already horizontal, then we can just keep them. So let me look at joint A. I'll be a little more logical this time. Well, joint A's got 100 pounds. Let's show the 100 in the same direction here. It's got 100 pounds right there. It's also got 119 up, pushing up, I should say. Now, FAC, we're just going to keep because it's already horizontal, so we don't need to componentize it. But FAB is a diagonal force. It's pulling up and to the right. So it's going to get a Y component, pulling up, and an X component, pulling to the right. There you go. Now let's do joint B. Well, let's start with our applied forces. I got 50 pushing down. I got 100 coming in like that. All right. Now, both of the internal member forces from joint B are diagonal, so we're going to have to componentize both of them. FAB is pulling down and to the left as I'm showing it right now. So it's going to get FABX over here and FABY over here. And FBC is pulling down to the right, so we'll show FBCY here and FBCX over here. Okay? Last force we need to show is C. We'll start with that reaction force, 69 pounds down. FAC pulling over here like so. And FBC up and to the right. So I'm going to show FBCX, FBCY. All right, now remember, if I have a joint, let's call it J. Okay. If my force is pulling away, that's going to be tension. If my force is shown as pushing in, that's going to be compression. That will become very important here. So what we're looking for now down at step 5 is a single unknown force in the X or Y direction at a single joint. A few things around here. See if we can... you know what? I'm going to pause the video here because I can only record for up to 15 minutes. So I'm going to stop there and we'll finish the video finish the problem in the next video.